So in this video, what we're going to do is we're going to look at trig identities, and you'll see what that means in a minute. But the key thing with this is if you want to skip straight to just using them, you can do that in the next video. Or if you want to really understand where they come from, this video is the place to start. So there is one key triangle that is going to give us both our trig identities. And that triangle is one where we have an angle. And I'm going to give that angle a special name. We're going to call the angle x. And the thing that makes this triangle very special is I'm going to give it a hypotenuse of 1. Now we know, and I'm going to do a little working over the side and then label stuff in a minute. We know that sine of x is the opposite over the hypotenuse. Well, from what we've labeled on our triangle, the hypotenuse is 1. So because the hypotenuse is 1 in this triangle, that means sine x will be the same length as the opposite in this very special triangle. So this will be sine of x. And you can do a very similar thing with cos. Well, cos of x is equal to adjacent over hypotenuse. And the hypotenuse is just 1 in this case. So cos x is the adjacent. So this is a very special triangle, but it connects for us sine x and cos x, and this is quite handy because we can now use some of the other properties of our triangle. First up, we're going to talk about tan of x. Now we know tan of x is opposite over adjacent from SOHCAHTOA, but we can fill in our missing information here. The opposite in this triangle is sine x, and the adjacent is cos x. And although we started with a very special triangle to get this fact holds no matter what x you pick, and that is an incredibly handy little identity, and we'll see that used in the examples we're going to do. So that's identity number 1. Identity number 2 also comes from this triangle, because being a right-angled triangle, Pythagoras also works in it. Well, what does Pythagoras tell us? Well, it tells us that if we square these two sides, now in maths we've got a special way of writing that. We square them by putting the square in there. We do that so it's clear that we're not squaring the x, we're squaring the sine. So it's sine of x all squared. And that's how we write it. And if we do the same with cos of x all squared is that. So two short sides squared and added. Well, Pythagoras tells us that must equal the long side squared. Well, square of 1 is just 1. And so we get a second identity here. And our second identity is sine squared plus cos squared equals 1. So this identity here is our second one, and it's a really important little identity as well. Now, one final thing to finish with. This identity, we sometimes use it in this format, but more often than not, we rearrange. Now, if I take cos squared off both sides of this identity, we get sine squared equals 1 minus cos squared x. So that is also a version of this by just taking cos squared off both sides. And we'll do that transformation when we look at some of our examples. Equally, if I take sine squared off both sides, then cos squared equals 1 minus sine squared of x. And having done that, we have two identities and some alternative, apologies, that should be a minus, two alternative versions of them, which actually we're going to use and we're going to see as we work through some examples.